Alright everybody, welcome back to another Ask a Dev Unreal Engine Live tutorial, where today we are actually going to be working on, I thought it'd be fun to build a radar screen, bottom left corner, top right corner, whatever. The idea being that you could see your enemies around you, where they are and stuff like that. I thought it'd be a fun exercise in blueprints and UI and all that kind of stuff. And also just getting a little bit ahead of myself, welcome to the stream. My name's Kevin. Thanks for being here. If you're watching after the fact, thanks for watching. As always, we do these live because we have just the right amount of crazy, I guess, to do that, and it gives you all a chance to see me stumble through some of this stuff and kind of debug it on the fly as well. Most of our ideas and topics, they come from our community. So speaking of community, thank you so much for being part of this adventure. They are literally, our community is awesome. If you haven't joined, you can find us in there's a Discord link down below. We also obviously have the videos and stuff like that, but people in there help answer questions, etc. Thank you to everybody for being so cool in there and helping answer questions along the way. As always, I really appreciate your support. My brain's a little bit scattered this morning. I'm running on 2 hours of sleep. There's lots of ways to support the channel. We have the PayPal tips down below, we have the Patreon, and then spreading the word is awesome as well. I think I said my name's Kevin. I can't remember. And I also wanted to give a quick shout out to 3 of our newest Patreon members, Mike C, Ben Pepper, and Anonymous. So thank you for making this possible. It's what allows me to keep doing this. So with that, let's take a look at a couple of things. So the way this usually goes, I'm going to go through the tutorial. We're going to set up a radar screen together. If you have questions along the way, go ahead and feel free to fire those up. I'll try to keep an eye on the chat. And then at the end, if we have time left over, I'm happy to stick around and help answer any kind of general questions as they come in, as well as any super chats or anything like that that pop up along the way. So who do we have in here today? Well, we have some new ones. Shife, I can see you. Good to see you again. Cyril, Sina, good to see you all again. Welcome. And DNF, it was great talking to you last night in the community. So let's go. We got stuff to do, right? So here we are. I'm hoping all the audio is coming through and you all would have told me if not. The goal is to put a radar screen in the bottom left that shows us where all of our enemies are. So what are we starting from? First off, from previous lessons, we are currently using Unreal Engine 5.41, but this should apply to almost every version since 5. Our starting point is the third person character project. You can probably use any project you want. And I think that's all of the stuff. Ronnie, welcome to the stream. Okay, so what do we need to do radar? Well, we definitely need some UI. So we're going to need a radar, like UI piece. And we also are going to need some enemies. So let's start with getting the placeholders in place for our HUD in our UI. So inside of our tutorial folder, we have a UI folder. What we're going to do is we're going to create a quick HUD. The HUD we are going to override in the game mode, and I'm going to show you how we can do this. But bottom line is we need a place to display our radar, so let's just go ahead and create a new blueprint class. And over here, actually, let me do one more thing for you all. Let me increase our font size so you all can read this a little bit easier. And then I do also stream at 4K, so if you can't read something, you can always go back and watch the high-res version once it's done processing. So here we go, blueprint. We are going to open all classes. I want to type in here HUD. The reason I'm going to use a HUD is because I want to override the HUD that's part of the default game mode. So let's just create this, and we're going to call this HUD radar, for example. Okay, and that is not going to do, there's not going to be a whole lot that happens in here. Generally speaking, what we can do with this HUD radar is in our game mode for this project. Remember, the game mode's the one that controls all the rules of the game and everything like that. If you look, one easy way to find it is if you look at the world settings over here on the right. If you don't see the world settings, they're usually up here under window. You can choose show world settings. You'll notice that the game mode override is currently set to the BP third person game mode. If I click the find button, it'll take me to the BP third person game mode. I can open that up and show you what we're changing. This piece right here, see where it says HUD class? Right now it says HUD. we're going to replace that with the HUD that we just made. Now, our HUD doesn't do anything yet. When we compile and save, literally nothing has changed. This is just the third person project. So, Lax, welcome to the stream. You made it to a live one. Very cool. Okay, so we've replaced our HUD, but our HUD doesn't do anything yet. So let's get a couple of placeholders in place just so we know our HUD is working. So I'm going to go back to our UI folder, and we're going to need a couple of things as part of our HUD radar. We need a widget blueprint for the radar. So let's create another, and this time we're going to create user interface, a widget blueprint. And I'm just going to select user widget. This is going to be the actual widget blueprint that holds all of the pieces to the HUD. So for right now, I'm just going to call this widget blueprint radar. Actually, I'm going to call this one more thing. I'm going to call this the radar HUD. Radar HUD components, maybe. It's super long and wordy, but I want you all to be able to keep it separate in your head. Usually I would just name it radar, but anyways. And then what we're doing is, if you've never used UMG or the Unreal Engine UI editing, we have a whole tutorial series on the basics of that, but basically, generally speaking, there's the designer view and the graph view. The designer view is where you kind of create your layout, and the graph view is where you put all of your logic. For now, what we're going to do is we're going to drop in a canvas, and I'm just going to do this to get it showing up. So here's our canvas. It covers the entire screen, and then just for kicks, let's drop in an image right now just to get this up and running. So we'll take this image, and what I want to do with this image is I'm going to anchor it in the bottom left, because that's where we're going to put our radar. Now, when we do that, it's going to automatically put in all the offsets and everything. I don't really want that. I am going to set it to be 300 by 300 because I think that's going to be a good size for our radar. And then I want to set my alignment, I believe, to 0, 1, because that changes where the pivot is. Okay, so pretend this is a beautiful circular radar screen that does the pinging and all that kind of stuff. So because we've got this, we've created this, what we need to do in our HUD is we need to tell our HUD to spawn our new radar UI piece. So, because right now, if we play, we're still not showing anything because our HUD doesn't actually use this. So here's what we're going to do. We're going to create a widget in here. And the widget we're going to create is our new radar HUD components, for example. And all we have to do very simply is add it to the viewport. Add to the viewport. And that is it. So when we play now, theoretically, we should have a big white square in the bottom left corner of the screen. So I like to work like this. A lot of times I'll get all the pieces in place, and then I will go through and start refining them. So we have a radar in the bottom left. It doesn't do anything yet, but we're going to be updating that as we go. Let me bring back our chat to make sure that I am keeping track of what you all are doing. All right, so control which mess with involving. Okay, cool. Okay, so now that we have that, there's going to be one thing that we want to do is, in general, even when you're starting out, we want to try to think and work modularly. So what we could do, for example, is in this radar HUD components, we could implement everything about our radar here as part of this HUD components, but I'm not going to do that. I'm going to create a new widget that represents just the circular map graphic, because maybe something else that I might want to display as part of this HUD would be like enemy counts or all those kinds of things. So I'm going to work basically compartmentalized, object-oriented if you come from a programming background, or modularly if it's easier for you to think of. So here's what we're going to do. We're going to create another widget blueprint. This one is going to be also a user interface, user widget. This one is going to be our widget blueprint, and this is actually going to be the actual radar map, for example. We'll call it that, just for clarity. And this one, what we're going to do in our radar is we are going to add in an overlay. So the way this works is you basically layer in, if you've ever done web development or anything like that, you basically use these panels as kind of like templates and placeholders, and then you add things to it that you need. So in this particular case, we have our widget, our overlay, and inside of our overlay, and let's go ahead and change the sizes. I'm going to change this to custom to be 300 by 300 because this is going to be the final size of our radar. So in here, what I want to put is I'm going to put in an image. And we're going to take this image and we're going to make sure it fills the whole panel, in this case, the overlay panel. So let's, over here on the right, under the details, we're just going to choose horizontal alignment fill and vertical alignment fill. Okay, so now we have that, but we want to make this round. I would like to have a round radar. And we have a couple options for how we do this. So if we look at the brush for this image 82, and let's just call this the, this is an image background. Okay, what we could do is we could go into Photoshop, create a rounded texture, import that rounded texture, and import that in as our backdrop with alpha and everything like that. But rather than doing arts and crafts, I thought it would be more fun to do it procedurally. So how is that going to work? In addition to being able to include an image, we can also do materials. So let's go back. Let's save everything just in case we get one of those lovely blue screens. And we'll go back and, hold on, let me resize some of these things. And then what we'll do is we will create a materials folder here. So new folder, let's call this matte. And I'm just going to set the color on this real quick to be green for materials. We'll go in here. Let's create a new material. And this material is, we're going to call material radar. And when we open this, we're going to make a couple of changes. One thing I like to work with is, because this is going to be a UI material, we are going to change the domain this works in. Right now, when you pick this output, this box here represents the final output of all the logic that we're going to put into our material. But right now, the domain, in other words, where the material is used, is currently set to surface. I'm going to change this to user interface. And that is going to change a lot about how the graphic and everything looks. And then I'm also going to change it to masked. That way I have the ability to use an opacity mask if I want to. And the other thing that I wanted to do, there was something else I wanted to do with this, which was, give me 1 second. User interface, we covered that. I will remember what that is in a second. All right, but we have our material, and let's just stick a color in. So I'm going to use a vector 3 for now. So if in order to get this to show up, all I did was I held the number 3 and I left click, or you can type vector 3 here, or vector 3 vector, constant 3 vector. Okay, so you can get it either way. But basically all this is this represents a color, red, green, blue, you can see it. Let's just set it to something like green to start with. So we have it. And we will fill this in to our color. So now we have a green square. Now, so we've created this texture, and if we go back just to see it working, we're going to plug it in. Rather than using a plain white image, let's go ahead and use our radar material. So you'll notice that when we do that, now our radar is green. And when we play in the level, if I've got, oh, I haven't actually connected that yet. Let's see here. This is our radar. Okay, so we've updated the material. We've updated our radar map widget, but our HUD is not using the map widget. Our HUD is using the box that we just dropped in. So let's delete that image. And instead of putting an image in, let's drop in our new widget, which we have compiled and saved. And so what we'll do is onto our canvas, we're going to drop our radar map. Okay, and just like before, it's going to show up in the top left. I do need to set the settings, so I'm going to adjust my anchors to be bottom left, and then I have to reset this, and I'm going to set my size to 300 here, and then I'm going to adjust my alignment. So now you'll see the changes that I make in the radar material. If I come back here and I change this to hot pink. If I apply that, when I go back to our HUD, you'll notice my HUD is hot pink. And when we play in game now, we have a hot pink HUD in the bottom left corner. So we're starting to get all the building blocks in place for what we're doing. Now let's go back to our material and start to have a little bit of fun. So first off, here's what I want to do. I want to make this round. So if we get a gradient, radial, I believe it is, radial gradient exponential. When we're working in materials, if I want to see what this looks like, if I right click, I can start previewing it. Look at that, it's circular. That's exactly what we want in order to fill in for our opacity mask for this. So if I stop previewing this, what you'll notice is I get a nice round pink circle. Instead, if I apply this and we go back and we look at our HUD, look, our HUD is also round. However, this opacity mask only does 0 or 1. This is not a translucency. The difference is translucency, you can fade in and out smoothly. Opacity, or the opacity mask is 0 or 1. So if the pixel is half or 0.51 invisible or black, it will be completely gone. And if it's, or vice versa, but basically it rounds it. If it's 0.51, it goes to 1. If it's less than that, it goes to 0. So what we're actually doing is we're not getting the full size. And the reason we're not getting the full size is because when we look at this preview, see how we have this fade? So what we're going to do is we're going to increase our density. To increase our density, I'm going to hold the 1 key and left click, and that's going to give me a constant. And I'm just going to pump this density way up. So when we pump this density up, what happens is it basically takes away the smooth edges. So now I have a very nice, clean, crisp circle. If I stop previewing it, you can see it's the whole pink thing. And if I apply this, when I go back to my HUD, you'll notice that my circle fills the entire HUD. And now when I play an engine, we have a nice green, or not green. It will be green in a second when I change it back to the right color. We have a nice pink radar HUD. And now there's a couple of things I don't like about this. This is super close to the edge. We'll fix those as we go. Let me double check how we're doing. Off the Rails, good to see you again. Welcome back to the stream. Okay, cool. So back to our radar. We're moving along. Now, what we actually want to do, so we are controlling our opacity using the radial exponential, which is cool, but we also potentially want to make some changes up here for this. So what I want is I want those nice green lines. Now, this is a little bit of a mind game using functions, and it might be easier, and maybe if we have time at the end, I can show you how to do it the texture way as well. But let's do this. We're going to do vector to radial, vector to radial, and let's be real here. I don't know all these things off the top of my head. I have to look these up, right? So I did a search. I was like, how do I convert a vector radial to a value and stuff like that? All right. And so then I discover, or I find pieces of other people's tips and stuff online. I do not know all of these things right off the top of my head. Also because I'm not a material expert. I'm definitely way more focused on the front end character stuff, but I'm going to multiply this by a value. All right. And if I right click and start previewing this, you can see what I get. I get this radial looking kind of fall off. And what I'm going to do is I'm going to use this as the UVs for a texture parameter. So let's create a texture parameter, 2D. And the one that I want to use is a grid. So in here, over on the lower left, I'm going to type in grid. And the cool thing is the grid just comes with the sample project. And I'm going to use this T grid. Okay, so if I preview this, nope, preview, start previewing, you'll see I have a grid. Okay, it's square. We don't want square, we want round. So the whole reason we did this vector to radial value is because this is going to take this, and when we feed this into our UVs, look at that. It made it round. That's cool. Okay, now what we can do now is we can adjust these values to get what we want. So if we go like say 0.7, 0.77, I want to use, yeah, okay, we'll use 0.77. That's pretty good, okay? But you'll notice when we plug this in, so now what we're going to do, if we plug this into our final color, if we stop previewing, because we're using the mask, all of the edges are cut off. So you don't see the outside edges. So if we apply this and we go back and we look at our radar component, look at that. We have a radar in the bottom left corner. It totally works. Okay, and obviously if we play, now our radar is in the bottom left corner and it looks like a radar. We're getting there, y'all. How are we doing time-wise? We're doing all right. Okay, so now there's a couple other things that I want to do. You'll notice that right now I have these nice lines, but I don't want them to be white. I would like them to be green. So what we can do is, because these are, this value is black or white, if I take black is 0, white is 1. If I take any value and multiply it by 1, it's that value, correct? So if I take green and multiply it by 1, I get green. If I take green and multiply it by 0, I get black. So if I simply multiply this color by our lines, what's going to happen is wherever it's white, it's going to be pink, and wherever it's black, it's going to be black. So if we connect this in, you'll notice that I have pink lines now. All right, so all we have to do is change our color. So if we just bring this up and we go green, let's go like 100 green, 0, make it a nice bright, maybe that's a little too, I mean, glow is good. Everybody knows that. Not really, glow's not good, but everybody loves glow. Okay, so we'll just call that good enough. Let's apply that, and you can see now in our HUD component, we now have a green radar in the bottom left of our screen, which is cool. Now, one thing I do want to do is, this is kind of killing me that it's right here in the bottom left. It's going to be really hard for our players to see this. So I am going to add in some padding. Where am I going to add in this pad? Oh, actually, you know what? I think I'm going to, let me see. If I've added padding, does it make it smaller? Yeah, I don't want padding. I'm just going to offset it. I'm going to offset it maybe 10, 20. Let's say 20 in X and negative 20 in Y. Just to get it out of that corner so that when I look at it as the player as I'm playing, it's a little bit off that corner. Just gives me a little bit of padding. Okay, so now we actually have our radar. We're good to go. Tutorial's not done yet though, because what we need to do is, now that we have it, we need the idea of being able to see our enemies on it. So we've done a little bit of material work, we've done a little bit of UI work, now we need to do a little bit of blueprint work. All right, is everybody with me so far? Okay. Natine, okay. Off the Rails is back. Natine, I have a couple of complete game materials. Not materials, I'm in the middle of this, yeah. A couple, including twin stick shooter and horde mode. That's cool. What if you pad one of the parents? Yes, DNF Jeff, that would work as well. You could wrap it, pad the parent, and then that would work. I just don't want to change the size. So there's lots of options in Unreal. There's more than one way to do many things. Okay, so what we need is, now we need a few enemies to detect. So let's make an enemy blueprint real quick. And what we're going to do is we're going to duplicate our third person character. And I'm going to call this BP enemy base, for example. Okay, and let's make some changes so we actually know these are our enemies. First off, they don't need any of this. All of this is for the player to control. We don't need any of this, so we can just delete it. Okay, and now that we've got that deleted, let's go ahead and change our mesh a little bit. Let's go with Manny for this mesh, and we'll go with the Manny blueprint. And what that's going to do is that's going to create a character that is now the Manny. Now, we also do not need the follow camera, and we do not need the camera boom. We don't need any of those stuff, because the enemies are self-contained. We're never going to control them, and so on. Okay, so let's go to our map, and let's drop an enemy in our map. We'll actually drop a couple enemies. Now, I want to be strategic about this as we're doing this, because we're about to get into the whole maths part of this. So I'm going to put a couple enemies in here, and what I want is I want our radar to be able to detect enemies within a certain distance. I don't want to show everybody in the game. I want to show enemies within a certain distance. So when we're testing this, I am going to strategically place these based on the player start. So this enemy is 100 units away, 1 square. That's why these squares are so important for layout. this enemy, if I duplicate it, and the way I did that, by the way, I held the Alt key and then left drag to move. This enemy is 1, 2, 3, 4, 500 units away if we move it up here. And then I'm going to do the same thing over here. Let's do 300 units this way, 1, 2, 3, and we'll do however many this is. This is 1, 2, 3, 4, 5, 6, 7, 700 units away. So we have some enemies now to test against, and sure, we'll put one behind us as well. Okay, so now that we have those in our scene, what we need to do is we need to make it so our radar understands how to see them and how to draw them. So we're going to need a couple other things. All right, so this is where we get back into the graph portion of our radar. Okay. Apologize for not hitting the mute button there. Okay, so in our radar map, what we want to do in the graph is, we're almost to math time. We're definitely getting there. There's going to be a couple things that we need to do. All right, and there's a lot of different ways that we can do this. So here's what we're going to do. On construct, let's talk about it real quick. We have choices right now. Our choices are, how are we going to update this radar? Like literally, how are we going to, what is going to be our update method? Are we going to every single tick get all the enemies in the scene and draw and move them? That's kind of expensive. I would like to default to something a little less expensive. So what we're going to do is we are going to get a list of all of our enemies within a certain distance by using a multi-sphere trace every second. And then what we're going to do is we're going to store that as our current list of tracked enemies. Then what we'll do is we'll take that list of tracked enemies, and those are the ones that we're going to draw. So every second we're going to update. That way we're at least thinking, I want you all to be thinking like from a performance perspective, even in the beginning. So that way we're not every single tick, and if you don't know what a tick is every, basically a game runs at 30 frames per second. So basically every 1/30th of a second is a tick. So that every tick we're not getting all of the actors, getting all of their positions, doing all the calculations, putting it in. So what we're going to do instead is every second we're going to get all of our enemies, and then every tick we're just going to draw the ones that we're tracking. That's the goal. That's the plan. So here we go. We need a couple of variables. So let's create some. Let's get enemy actors. Enemy actors. And our enemy actors is going to be actor. It's going to be of type actor. We're not going to do any casting or anything like that. And we are going to make it an array. Okay, so this is going to be where we're going to store all of our enemies. And we are going to use tick, so we'll move this down here in a second. Okay, and then I'm also going to create a variable called detection range. Detection range. Okay, and then what we're going to do, that is going to be the distance that our radar is effective. And so this is not going to be an array. This is going to be a single float. Okay, and we'll get into that one in a second. So how do we set it up so every second we get all of our enemies in scene? If you've watched a bunch of our other tutorials and stuff like that, like the twin stick shooter and other things, we're going to set a timer by event. Now, when we do this, the way this works is this is going to call another function every so much time. So we're going to set it to every second, and we're going to set it to looping. So every second, this thing is going to call an event that we are about to define. And then that event that we are going to create is a custom event. And we are going to name that super verbose. We're going to call this event update enemy detection. That way it's clear, one for understanding and also for the next person who comes along. And then we're going to connect this. Okay, and for now, let's just print a string. We're going to print detecting. We're going to make sure this is all working before we get too far. So let's go ahead and press play. Now theoretically, if we did this right, every second, you should see in the top left, you see it's printing detecting every second. So we know we have it set up right. It is actually doing this, which is great. Okay. So now that we have our timers by events, I'm going to do this the frowned upon way at first because I just want to get it working. So stay with me. We're going to get all actors of class. Try not to groan everybody. Just know that we're going to do it, quote, the wrong way first. Actually, you know what? No, we're not. We're going to do it the right way first. Okay, let's talk about it. First off, get actors of class is not well liked. It's generally speaking, a lot of times it's considered to be not super performant. That's why it's not there, and it can be wasteful because you're getting all the actors in the scene, and then it has to go through all of them and see if they are that class, which we generally don't want to do. So rather than doing that, what we're going to do is we're going to do what is called a multi-sphere trace. So what that is it's basically going to create a sphere, and anything the sphere touches, it's going to return to us. So let's do a multi-sphere trace. Actually, let's just do sphere trace. I want to show you something. Sphere trace. Okay, you'll notice that there is a sphere trace for object and a multi-sphere trace for objects. The difference between these two is a sphere trace for objects will get the first one, and a multi-sphere trace will get all of them. Okay, so what are we going to do? Well, we want this sphere trace to happen. It needs a start and an end. The start, let's get our owning player pawn. That is the person who this UI is on. In other words, our player. And with that, we are going to get their position, get the actor position, get the actor location. That is going to be our start point. Okay. Now the radius of this sphere trace is going to be our detection range. So we can plug this in. I also want to compile this and set the default value. It's not happy yet. That's fine. We'll fix that in a second. Our default detection range, let's do 1,000. Or actually, let's do 500. Okay, compile that. We still have an error because we do need an end and a couple other things. So where is our end? So basically what this does is it projects a sphere in any direction you tell it. But we want to use it. We want to cheat. We're going to project it straight up. And the reason we're going to do that is because we're going to cheat it to use it more like a radius instead of using sphere overlap actors. So in order to project it straight up, you have to know that in Unreal Engine, up is Z. So if we just project this, let's say 250 units straight up, this will basically project it straight up. Okay, so we have a start and an end, which is straight above the sphere trace. And then the object types we're going to get is going to be, we need to make an array out of this. If we type make, it'll make it for us. And then we want all the pawns. And I'm going to show you something we have to do to ignore pawns here in a second. And then just so you guys can visualize this, let's just, this is happening every second. So let's do this, let's draw this thing every second. So you all can visualize what this looks like. So now when we play, every second, you can see this sphere trace that's happening if we eject. So what's happening here is look at all those hits. Right? Every actor within this thing is going to return a bunch of these hits. So red means it, or no, green means it, I think red means it hit something, and green would be where it ends. So you can see how far up we're kind of projecting, and this is going to get everything within that radius. Okay? Is everybody with me? Yes, correct. That is Shife. So sphere trace gets the first detected multi-sphere gets all within the radius. Yes, that is true. Okay, cool. So now that we have that, we can turn our debug off because now we can visualize in our minds what this is doing. And then all we're going to do is we are going to, for every single thing that it hits, we're going to do a for loop for each of these. And with this, we're going to break this hit result. And as part of the hit result, so what's happening is it's returning to me all of the hits. What we're going to do is we're going to take this hit actor. This is the actor that we want. So we know who got hit. And what we're going to do is we're going to add this to our enemy actors. So let's get our enemy actors and let's add this. Add unique. Now, why are we adding unique? We're adding unique because I don't want double entries. I want unique hits. Like, for example, you saw all those red dots on the actors. Technically, those are hitting the actors in the hands, the feet, the head. I don't want all that. I just want only the actor. That's all I need. So for each of the hits, we're going to store that in our enemy actor array. And with that, we now have a list of characters that we want to draw. Okay, so let's see how we're doing here. Now, what we're going to do is we are going to need to be able to draw a blip, a little red dot for each of our enemies. So let's just, for kicks, let's just double check this is working. Do we want to do that? No, let's just, for time's sake, let's just say we know it's working. We know we need a blip. So let's go make a blip. We do not have a blip as part of our UI that we can use to draw yet. So let's go back to our third person, our materials, and I'm going to create a new material. Let's duplicate this. I'm going to call this material blip. This one, we're going to make a couple changes to. And we don't need a bunch of this stuff. We don't need the radial. We don't. Let's keep the multiply for right now, and let's make our blips red, for example. That is definitely not red. That is definitely orange. Okay, so now we have red. And then what I want to do with that is I want to also, let's just give it a little bit of style. We have our radial. That makes it radial, but rather than doing 100, let's do 0.5. And then let's multiply that by our color, and we can connect it to the radius mask. Let's see, what am I missing here? Oh, not for the density. I want to plug 0.5 into the radius. Okay, so if we look at this and we plug this into the radius instead, I think this will make this a little bit softer, and then we can change our color to be a little bit softer. Okay, so now we have like a little bit of a fall off, getting a little bit too arts and craftsy, but whatever, it looks fine. So let's save that. Okay, now we have our blip texture, but now we need the ability to use it. So here's the deal. We basically want to add blips to our radar. So to do that, what we're going to do is we're going to create a widget for a blip. Now, the reason we're doing this as a widget is because right now I'm showing you how to use a red dot. You will hopefully take this tutorial if you want to, and you can extend it. And what you can extend it to is different blips for different enemy types. You can change it so that blips actually have direction. There's lots of different things you can do. And that's why we're working modularly, so that you all can update and do these things how you want. So let's go back to our UI folder, and let's create a new user widget, user interface widget. This is going to be our widget. This is a user widget, and this widget blueprint is our blip. All right, when we open this up, this one is going to be pretty simple. We're going to drop in a canvas panel, and I want this blip to be, let's say 10 by 10, I believe. Well, let's get into it. So let's make our screen size, not our screen size, our fit size to custom 10 by 10. So this is what I want it to look like. And inside of our canvas panel, I'm going to put an image. So let's put an image in here. Now our image is too big right now. So what we want to do is we want to set our image size to 10 by 10 as well. Now it's hard to see because of the anchors, but you can see we have this white dot. I cannot zoom in any further on this right now. But what I want you to note is where the center of this blip is. It's offset because the anchor is in the top left. We want this image to actually be centered right on dead middle, because that is going to be where it is when we put it on the radar as a blip. So what we need to do is over here in our image settings, we have our 10 by 10. We also want to offset, let's see here. How am I going to do this? Okay, so let's take this and just anchor this in the middle. Okay, so it's now that moved the anchor to the middle, and then what we need to do is change this offset to be 0, 0. I think that'll do it. Nope, that's not what we wanted. We want the offset to be, oh wait, our position is fine, our size is fine, our alignment is 0. Hold on a second, you all. Pivot, I think that's the one I want to change. Why is this moved down? 0, 0. Oh, y'all messing with me. So our anchors, let's take a look at our anchors here. let's 0 these. There we go. 0 these out. Okay. And then we have our position. We'll go 0s on the position, 10 on the size. We're not going to size the content. We are still not getting that lined up properly. Alignment 0, 0, Z order, draw as. All right, well, let's just roll for a second and we'll come back to this in a minute. But we have our blips. We want to use our blip color. So let's just type in blip here. And that will at least turn our blip to be this red dot. And let me double check what's happening with our canvas here. Our canvas transform is 0, 0. We have 1, 0, 0. Our pivot's a 0.5. We have no clipping or anything like that. Huh. That's kind of wild. Okay, so I'm just changing the anchors here for a second, trying to find the right setting. Because I want this lined up in the middle. 0, 0, 0. Size is 10. Okay. That's closer. We'll call that closer. We'll come back to that in a second. I don't want to get too lost because we'll lose momentum. So we have our blip. Now what we need to do is we need to add these blips to our radar map. All right. So here's what we're going to do. We need on our radar map, on the designer, I'm going to add a another canvas panel. And this is going to hold all of our blips just so that they're all in one place. So let's take canvas in here. And I'm going to put this under the overlay. I'm going to rename this to be our canvas panel. Blips. I'm going to make this a variable. And let's make sure, right now you'll see it's only in the top left corner. It's too small. We need to make sure it fills the whole space because this is going to be our 0 to 1, right? All right, so we filled our whole space with it. And now that this is a variable, we can come back over here. And what we're going to do is we're going to add a blip for each of the actors. So here we go. Whew. All right, so first off, we're going to take our blips. And the first thing I want to do is I want to clear what's inside of our canvas panel for the blips. So if there's any blips in there, I want to clear them out. So let's just clear the children. This is kind of like an initialization thing. So we'll just clear them. And then what we can do is we are going to take all of our enemy actors. And this is where the maths is going to start. So for each of these, what we want to do is we want to calculate where it is relative to our character. So let's get the actor location. So we have the actor location. This is the actor location for our enemy. Okay. And what I want to do is I want to get the character who has the HUD, right? The player in this case. So let's get the owning player pawn. Let's get their position, get the location. So now we have two locations, right? We have the player and we have the enemy. So let's get a vector from the player to the enemy. So to do that, what we're going to do is we're going to subtract. So we're going to subtract the enemy from the player, and that gives me a vector. That is a, remember, if you haven't looked at our vector tutorial, basically a vector is just simply a direction and a magnitude. All right, so now that we've done that, what we want to do is let's take, oh, interesting. Okay. We're probably gonna mess this up a little bit, but all I want to do is I want to take this. This could be a big distance. This could be 1,000 units, for example. But the thing is, our UI is only 300 units tall. So let's just say that our character's standing right in the middle of the radar, and we know a person is 1,000 units above us or in front of us. Well, when we go to put that dot in there, we need to take 1,000 and we need to remap it down to 300. So we need to do a little bit of dividing in here. So let's take our vector here and normalize it. And we're going to have to come back and do this. So if any of you are thinking ahead saying, wait, you're not accounting for the player turning or anything like that, you are dead right. We are going to come back and do that as we go, but I want to step through it so that you can kind of see not the mistakes, the learnings as we go. Okay, so we've normalized that. And then what we need to do is we need to take this. Remember I said we need to recalculate to fit inside of our display. So if we take this and we get the length of this vector, this is going to tell us the total distance, right? All right, and then what we'll do is we'll divide this by our detection range. Okay, so let's say that they're 1,000 units away and our detection range is 500, so we're detecting everything in the range of 500, or if they're 500 units away, hold on, let me say that again, just because that was confusing. I was thinking we were talking about 1,000. If they're 500 units away and our detection range is 500, we need to take that and we want them at the edge of our radar. So we're going to take this and we are going to multiply it by 150. And the reason we're going to use 150 is it's half of 300. Okay? And then we're going to take that value, that becomes a scalar that we can use to determine how far away something is. We're going to take this normalized vector and multiply it by that. We'll walk back through this here in a second. Let me convert this pen to a single float and we'll connect this in. All right. So what this does is it basically figures out where the enemy is and it basically remaps it into a distance that we can put onto screen space. All right. And then what I'm going to do is I'm going to multiply. I'm going to multiply this value by, let me show you what happens if we do 1. Oh no, I accidentally opened C++. Hold on one second, y'all. Okay, so I'm going 110 because I don't care about the Z value, right? I only care about, we're only looking at this in 2T. And what we're going to do after all of that math is we are going to create a widget. That was all just so we could create a widget, you all. Create a widget. The widget that we're going to create is going to be our blip. So let's create a blip. Okay, and with that blip, what we want to do is we want to set the render transform, set the render transform, and we're going to make a transform here. And we also want to take our canvas panel, which is our blips, and we are going to add this newly created widget as a child. So add child to canvas. And I think I just used plain old add child before, so let's just see if this works. So that's going to add it, and now we need to make this transform. So let's make a transform, make a widget transform, and the translation that we're going to use is if we split this pen by right-clicking and choosing split, right-clicking and choosing split. We'll drop this in here, X to X, Y to Y. We'll keep our scales, we'll keep everything else. So theoretically, at its base case, we're clearing the radar widget of all the blips. For every actor, we're going to create a new blip, and we are going to position the blip and add it to the canvas panel for the blips. Now, all of this math, all this does is get our positions. Now this is probably going to be wrong. They're not going to be in the same place, but let's just even see if we have any dots. Oh, we do. Look at that. You can see the dots kind of in the top left, but you can't really see them super well. So let's just blow these out so you all can see these a little better. So let's take this and go, let's go 20. Maybe that'll be a little bit brighter. Okay, so you can see the dots. Now, they're kind of in the wrong place. They're in the wrong place because our widget radar, where is 0 on our widget radar? Let's go look at our widget radar. If we look at the designer view, this point right here in the top left corner is 0, 0. So the middle of our radar is actually 150 over and 150 down. We did not account for that offset when we were placing our blips. So over here, what we need to do is, rather than multiplying by 100, for example, what we want to do is let's add. Not an array. I want to add, like as in math, or add. I want to add 100. Oh, I did it again. 150. Go away, C++. Let's go 150 on the add and 150 here. And this is going to be what we're going to use for our X and our Y. So that will offset it by the distance for our radar. So look at where they show up now. We have several different blips that we're looking at. However, they seem to be in the wrong place. So if we move, they do move when we move, okay? But even though I'm facing this enemy, when I turn, notice that the blips don't turn. So the configuration's wrong, because our radar is not taking into context which way our camera is facing. So they're all in the wrong place. And also you'll notice we have one red dot in the center. That one red dot in the center is us. So let's account for a couple of those things. Let me go back and catch up on questions. Position, Ivanhoe, welcome to the stream. Thanks for chiming in. Yeah, we're gonna go back and fix that in a second once we get this all. Clamping the ones to 300 could make this all a function. Set the timer, not to run radar every tick, not to get ahead. Yeah, DNF, we might do that, but there is a good reason to run it every tick, which we're gonna get to here in a second. Okay, cool. So back to what we were doing. What we want to do is we want to take into account our rotations. So let's do that. So what we want to do is we want to basically, after we do this addition, okay, before we do all this vectorization and normalization, we want to take into account our owner pawn's rotation. So let's get the control rotation here. Get the control rotation. Okay, and with that, I am going to take the output of this, oops, and I'm going to rotate this vector. And I'm going to rotate it by our controller rotation. And then that is what we're going to feed into the vector length and the normalize instead. So what's happening is we're making a vector that goes from us to the enemy. Then we are taking that and we're accounting for our face. So we're taking that vector and then we're rotating it to account for our camera facing. Then we're going to get the distance and the normalization, and we're going to do all of our calculations and stuff we were doing before. So let's see if all of our blips are in the right place now. Okay, so they're definitely rotating now. So we've definitely done something, and you can see, but they're off by, it looks like 90 degrees. Okay, that makes sense. Why does that make sense? That makes sense because our player character's pawn, if we look at the BP third person character, let me find it. Here we go. You'll notice if we look at the viewport, the character's facing down X, and there's two ways to look at this. It's either a negative 90 or a positive 270, so anyways, the point is logically it makes sense why it's off by 90 degrees and why we're going to account for that. So rather than just getting the control rotation, we are going to combine. We're going to do something called combine rotators, which is literally just rotator math, and I'm going to add in a 90 degrees here, not 900, 90, and we'll replace this. So now, as we're stumbling and fumbling through this, now theoretically we have, did we go the wrong way? Nope, they're in the right position. Are they? Oh, I guess it's negative 90. Let's try negative 90. When vector math becomes fun. Okay, right, left. I think that's a little more. Everything is, okay, so we have the one. Everything is flipped, it's reversed. So we're gonna do one more thing. we are going to take this rotator and I'm going to actually flip this. I'm going to multiply it by -1 to flip it. And I am going to go back to a +90 just to test that first. And this is all literally about getting the blips to show up in the right place. So in screen space relative. Okay. So it's not that way. It's this way. -90. Let's try that. There we go. We got one on the right. There we go. So this, you can see now, we have the character that is closest to us is right in front of us, which is great. Okay, now we do have a little bit of a problem, and that is because our detection radius is, what's happening is as we go outside of the radius, we're not updating our actors. So they're still being tracked, even though we've left the radius. So let's go back and do a couple things. If we go back to our radar map, we are clearing our children on tick. Right here, every time we update our detection, what we want to do is let's clear our enemy actors. So let's clear these too. So we'll clear these. Okay, and then the other thing that I want to do is before we create the blip down here, here, I don't want to create the blip if they're not in range. So let's put in an if test here. And the if test that we want to do is we want to see if this vector length is less than the detection range. So let's do a less than here. And let's plug in our detection range. And then if that's true, then we will show. So to get a branch, you can actually right click and type branch. That's one way to do it. But I just like to left click and hold B and left click because it's faster. And then we'll connect in these pins. So if this is true, we will create the blip. So these two things together, clearing out the blips and only drawing a blip if it's in range, should keep it so that our blips are only inside, and as they leave the detection radius, you'll see them disappear. So you can see them disappearing over here on the left. Okay, now it is possible, and this is important to understand, and now we can get into, actually before we get into the discussion, let's do one more thing because I want to add to, actually let's start the discussion. So here's what's happening. If the enemies are moving very fast or the player is moving very fast, you'll notice that the detection is not fast enough. So when I get up here, all of a sudden the enemy shows up right next to me. That's because our detection is on a timer. It only updates every second for all of the enemies. So this is where you're playing a little bit of a juggling act. From a performance standpoint, what cadence, what interval of looping time do you want so that enemies aren't just appearing next to your player versus the performance of updating this every tick? We have branched this, we've separated this out, so our detection is separate. I have seen implementations of this where the detection happens every tick as well. But I wanted to at least pitch the idea that there is a reduced number of sphere traces that we might be able to do, and what is that acceptable tolerance for your player experience. And this is the mindset that I want you all using as you're thinking, like, where is this? Because this is all a give and take. You do not get to do everything you want to on tick, especially if you're on mobile. So let's set that to 0.25 now. So let's see how fast it is before this enemy shows up on my radar when I'm running at him. Oh, that's pretty good. It's pretty good. 0.25 is pretty good. Like, it's not like the character's just appearing next to me. So let's try 0.5. Maybe that's enough. You may not care. You may be ticking on a Threadripper crazy machine, but some of us are running on toasters. And see, now at 0.5, it appears right inside that second circle. So 0.5 is not fast enough for me from a player experience. But the point is, you can now change this. Now, there's one other thing that we do need to fix in here before we do one last change and have our kind of chat. Actors to ignore. Remember, we're drawing ourselves as an enemy because we're not doing any casters or anything like that. So one thing I want to do is I want to make an array. And in here, I'm going to plug in myself. This is going to be the actor to ignore, one of the actors to ignore. And the reason for that is that way we no longer have the red dot in the middle. It's confusing. Okay, so right now we're seeing all of our actors that are within 500 units. If we go back and we change our detection range to 1,000, for example, this should auto scale everything so that it still fits on the map, but you'll notice the scale's different, right? Now we can see this enemy that was way over here off to the left. And as I walk away, it kind of keeps track of everybody together. All right, so let's make one more fun change. Just so you can see why we're doing this on tick and not every second. Other than I might be moving too fast, the enemies might be moving too fast. So let's take our enemies and let's, in here, let's do begin play, add event, begin play. Let's do another timer by event here. Timer by event. Timer by event. Set timer by event. And we're going to make a custom event here. This is going to be a very quick and dirty AI. So this is going to be event, random move. And we are going to get a random location and navigable radius. The origin is going to be our self. Get self. So each enemy, actually we don't even need to do that. We can just get actor location here. Get actor location. Not location. Okay. So each enemy is going to find a place around itself, let's say within a radius of 2,000, and it is going to simply just simple move 2. Let's try AI move 2. Let's see if that works. AI move 2. Location or actor. The controller. I think we may need to plug in our controller. So let's get the controller from here, because this is the pawn. Get the controller. We're going to plug that into the controller. The location that it's going to go to is there. And interesting. Actually, I said I wanted the AI move 2. For some reason, it gave me the other one. Here we go. The pawn. So let's get the self. See if this works. Okay, the location is going to be the destination, the acceptance radius of 10. That's fine. And so we're going to do this every every 2 seconds. Let's say 3 seconds. 3 seconds. Looping. And also, so what's going to happen is begin play is going to, let's just go ahead and start it and you'll see what will happen if they even move. They don't move. Why don't they move? One reason is because they don't know how to navigate yet. So we need to add in a nav mesh bounds. How do I know this? Okay, first before I add this, if I press P, it's going to draw all of the nav mesh that the enemies can use. There isn't anything that's showing up. So we need to add a nav mesh bounds. Nav mesh. You didn't know we were going to be doing AI today, did you? Okay, so let's take this and move it down and get it to overlap our level. Okay, so you can see anywhere inside this nav mesh bounds is green, which basically means that's where the enemies can go. So let's go ahead and make this wider so that they can basically travel throughout the whole map. And there you have it. I'm going to press P again to get rid of that debug kind of view. And then after 3 seconds, they start moving. Okay. Now, our radius must be really, we must have really messed up our radius here. Get rid of, oh, we did 200. Let's do 2,000. Okay. Okay, now they're moving. Okay, so here's where we go, and now we can have this conversation about tick or not. When the enemies are actually moving, if you're only updating every second, they will be able to get within a certain distance of me long before it's able to register. So they'll basically just appear next to me. So the reason I have, at least for the purposes of these learnings and being able to help you all think modularly, understand the importance of tick, how you might separate this stuff out, is the reason we're only ticking across a specific group of actors is I don't want to tick across everything. I only want the ones that are actually in the radar. And we're using this timer by event as a way to gate that and control how often. And at 0.25, it is fast enough that it actually still feels good to the player to be able to see these. Now, one other thing I wanted to point out for your timer by events is you'll notice it takes 3 seconds for the enemies to start moving around. Why is that? That is because if we go back here, we look at our enemy base. When begin play happens, timer by event starts. It doesn't fire right away. It doesn't fire this event till it hits the first 3 seconds. If you want this random move to start right away, what you need to do is you need to call event random move right here. So what's going to happen is begin play, set up the timer by the event. So this is where we're going to go in 3 seconds, and then just go ahead and call random move. So now when we start, they'll start moving right away. So that's just a quick little nuance thing to be aware of. But I think that's it, you all. I think we did it. We basically went through, how do we do for time? 12, we're a little bit over, not too crazy. But we basically went through, we did a bunch of stuff. To do that. I think the one thing we didn't get going is we did not go back and fix our blips. Do you all want to go back and see if we can fix our blips here real quick? I'm just double checking for any questions. And yes, you can definitely make a bunch of things functions. You can do all kinds of stuff to save stuff. Okay. Yes, DNF Jeff, I agree. So DNF Jeff is pointing out the sphere trace might be registering more. And like if we go back and we take a look at this, part of the whole reason of working the way we're working and thinking modularly is what we can do now is we can go in and we can customize this. If we find that the sphere trace is too much, it's very easy for us to do a sphere overlap instead, for example. Okay, we could just grab a sphere overlap within a radius. Everything else is the same because we're just going to take the out actors and feed it in instead. So whether or not we use a sphere trace, a sphere overlap, you could use a sphere on your character that is like an overlap sphere. You would actually have to do some performance testing to see how much of an issue that is. But while we're in here, let's see if we can't figure out this widget blueprint blip. And I believe we saw, okay, that's -5 and 5. Nope, -5, I think. Oh, actually we want -2.5. It would be -2.5 and 2.5. 2.5. 2.5. Nope, -2.5. Okay, I can't quite tell. That definitely looks more centered. Anchors. If we go top left. That is so small. You know what? Let's make our image bigger so we can see. Let's go 20 by 20. Let's go 20 by 20. Oh, and it's also, okay. -10, -10. Yep, that did it. Okay. So I feel like we should be able to specify our canvas. Here we go. Let's try this -10. Yeah, let's do this. I like this better. -10, -10 on a canvas. And then what we'll do is we'll zero out our blip. So it's right in the middle. So our blip has no offsets in it, which is cool. Okay. Now we'll have to change these numbers when we go back. But at this point now, our blips are going to be giant, but you can change the sizes of your blips and things like that. So effectively what we did is we shifted the canvas up and over, and then everything underneath it is just centered. And for the purpose of the blip, that works. Ronnie, thanks for hopping in the live stream. Andrea, welcome. Thanks for coming. Everybody who hopped in afterwards or as I was going, I didn't get a chance to see everybody who hopped in. Thanks for hopping in the stream, checking it all out. Did anybody have any questions before we wrap up for today and I go back to the day job? What'd you all think? Okay. I'm just double checking that we didn't miss any questions. Dark Spirit, thanks for hopping in. Screen Apple, also thanks for hopping in. Okay, great. So, as always, thank you all for being part of this adventure. You all are literally the best part of this whole thing. I learned a ton from you all's questions, but if you're watching this after the fact, you have comments, thoughts, things, other videos you think we should do, throw those down in the comments down below. Don't forget, we have the Discord. Also, if you're watching this, you've found our live section. We do have a lot of live tutorials. And hopefully I will see you all in an upcoming live stream, maybe next week. We try to do these each week. If I didn't talk through that, like I said, my brain is a little bit scattered. We do have videos coming out each week. So this week is either going to be another control rig video or another UI character picker video. I'm not sure which one's coming this week, but we have a bunch more stuff coming. But once again, big thing is, thanks for being part of the community. Thanks for supporting me on this adventure. And I will see you all in the next live stream. Take it easy.